Hello everyone, I am Anish Verma and I will be presenting my term paper on massively parallel processing. What is massively parallel processing, or MPP in short? Massively parallel processing is a paradigm where many nodes work in parallel to accomplish a task. Unlike conventional parallel processing, there is no memory sharing in massively parallel processing. Each node consists of personal input and output devices. Massively parallel processing is used particularly in organizations that handle enormous amounts of constantly growing data. Shared nothing architecture. Processing units share MPP or massively parallel processing databases. Information can be exchanged among processors thanks to a configuration of data pathways known as interconnect. The design for MPP is typically more difficult. It involves consideration of how to divide up a shared database across processors and how to distribute work amongst processors. A shared nothing or a loosely coupled system is another name for an MPP system. Now, we will be talking about history of parallel processing. In initial computers, only a single program could run at a time. There was no parallel processing. Then, early parallel processing techniques were developed, which allowed multiple programs to run concurrently in an interleaved fashion. The system would begin an I/O operation and run the processor demanding software while it waited for the operation to be finished. Time required now to finish two jobs was reduced in half because they were being processed parallelly. Multiprogramming was the following advancement of parallel processing. In a multiprogramming environment, the processor was made available briefly to a number of user-submitted applications. Users perceived it was an illusion that all of the applications were running simultaneously. These systems were where resource contention issues initially appeared. Explicit resource requests created the deadlock issue, where several requests for the same resource would essentially block the application from obtaining it. Vector processing, another effort to boost performance by performing several tasks at once, was vector processing. It is the next step of multi-programming. In this instance, machines were given the ability to add, subtract, multiply, or otherwise modify two arrays of integers with just one instruction. This was useful in several technical applications where vectors or matrices naturally appeared as data. Vector processing was less useful in instances where the data was not formed properly. Multiprocessing. Multiprocessing was the next development in parallel processing. These systems divided the work that needed to be done across multiple processors. A master-slave setup was included in the earlier versions. One processor, known as the master, was designed to handle all of the system's operations, while the slave simply carried out the duties given by the master. This structure was required since it wasn't yet known how to configure the computers to work together to manage the resources. Now we'll talk about Symmetric Multiprocessing System SMP, which is a crucial development in parallel processing. Every processor in an SMP is equally qualified and in charge of overseeing the movement of work across the system. Initially, the aim was to give programmers the impression that single processor and multi-programming system and SMP systems are precisely the same. Even so, engineers discovered that by running a few out-of-order instructions and making programmers deal with the added complication, performance of the system could be increased by somewhere between 10 and 20%. In this diagram, we see the SMP system. Here we can see that multiple processors share the same RAM and system bus. Every CPU does not have a different RAM. This will be the deciding difference between multiple uh, massive processing, massive parallel processing. Evolution of MPP, the time required for propagation of data from one area of an SMP system to all other sections of the system rises as the quantity of processor increases. So this is the limitation of our SMP system. To solve this problem, message passing method was developed. We talked about this in our introduction too. The changed value of an operand is only sent to the programs that really require to know it, as opposed to being broadcasted to all components of the system. The message transfer between applications is supported by a network rather than shared memory. These systems are known as massively parallel processing systems. Now, if we compare this diagram to the SMP system, we can see that in this system, message passing moves data through the system. Each CPU has a different RAM, and the core principle behind MPP is message passing system. Architecture. The MPP database architecture majorly comes in two forms. The first is grid computing, and the second is computer clustering. We will be discussing both of these architectures in detail. Grid computing. So, in grid computing, a distributed network of computers is utilized, which means the network consists of a lot of computers in a distributed architecture. As resources become accessible, they are utilized. This is the major thing in grid computing. As resources become accessible, they are utilized. This lowers the cost of hardware, such as dedicated space for servers. So instead of the dedicated space, the resources are just utilized as they become accessible. However, this grid computing, it may restrict capacity if too many requests are being handled at once, or if the bandwidth is being used for other operations. A computational grid can offer the necessary infrastructure for processes demanding very massive computation and input-output capability. Just like an electricity grid system distributes energy to scattered location on request. So a grid computing and parallel computing is analogous to an electricity grid that distributes energy to scattered location on request. There is no dedicated uh, uh, there is no dedicated electricity resource. It is done on request. In this diagram, we can clearly see how grid computing works. We have users, we have administrators, there is this management, and as the resource as the resources become available, the resources are shared. The second architecture that we will be talking about is computer clustering. So, a computer clustering connects the nodes that can manage several jobs at once by interacting with one another. Hence, the MPP network will respond to requests more quickly when more nodes are connected to it. So we can look at this in such a way that a cluster of computers are formed, and it it becomes more powerful and can solve problems more easily rather than single computers. A computer cluster refers to a group of connected independent computers that may cooperate and act as a single unified pool of computing resources. With standalone activities, clustering investigates huge parallelism at the task level and obtain high availability. So, in massively parallel processing, high availability is really, really important. As we will see further, scalability is also an important factor. High availability clusters, as we can see in this image. The use of load balancers is there, and these servers are made into clusters which can be used to solve certain problems which needs little more power of computation or a little more speed. Now, as I said before, we will be seeing the advantages of massively parallel processing. Why are we doing this? We know parallel processing works, but what about the massively parallel processing advantages? Implementing a MPP system has benefits more than just quick query processing. So in previous slides, we saw that it becomes more powerful and it can perform certain duties which needs more computation and more power. But what else? So the first thing that MPP solves is scalability. MPP databases may expand the architecture's nodes to accommodate more nodes for storing and processing bigger data quantities. So scalability is really easy in MPP databases. The second thing is cost efficiency. To complete jobs, we don't always need to purchase the newest, most costly hardware. This is the same thing that we studied in cloud computing. And like if we study Hadoop for that matter, that cheap hardware is being used. The third thing is elimination of a single point of failure. Other nodes can fill in if a node goes down for any reason, while the failed node is being brought back into the mix. So, as there are a lot of nodes, they can take responsibility if one node goes down, and then that node will have the time to get back up. The fourth advantage of an MPP system is elasticity. It is possible to add nodes without needing to make the cluster as a whole inaccessible. So it's not that we need to stop the whole cluster when we are adding nodes. We can just add nodes on the fly. Everything has advantages and disadvantages. So now we'll see the disadvantages of MPP systems. The major disadvantage is data structuring. It is a common problem with MPP systems since they do not handle unstructured data. Even structured data, example from PostgreSQL or MySQL database, needs to be processed to ensure that it conforms to the MPP structure. This is due to the fact that MPP databases are often columnar. This helps in speeding up the processing of analytical queries. And yeah, now we will be talking about a real world example of MPP, which is Redshift. AWS Redshift is really a cloud data warehouse that employs columnar storage and an MPP architecture, which makes analytical queries incredibly quick. MPP is quite similar to Hadoop's distributed file system. Additionally, it is SQL based. That makes it simple for data analysts to use. Redshift is a database, not a distributed file system like Hadoop. Hence, it can only support structured data. However, Redshift Spectrum, which enables simple S3 querying of unstructured data, is also available. We can see the basic Redshift architecture in this image, which contains leader node, computer nodes, hardware optimized for data processing. Now, we will be comparing Redshift with Hadoop. MPP databases have a share nothing architecture, which is not the case in Hadoop. Datasets don't cross across, and a network is used for all communication. Each server or node has the data that it is in charge of and the processing capability to evaluate that data. MPP databases are more simple to implement and manage as a result. Additionally, affordable cloud MPP databases like Amazon's Redshift database allow SQL-based business analytics applications like Tableau, among others. So we can see there are certain advantages of Redshift versus Hadoop. In conclusion, a kind of a cooperative processing of the very same application by multiple processors is known as massively parallel processing. Many threads of the applications are handled by each processor, which also has a separate OS and a memory space set aside for it. Numerous processors working together to process an application may at time number in the thousands. A real life example of MPP is Amazon Redshift. Thank you.